Everyone, welcome to Memgraph Community Call. This time we have Josip with us from the engineering team, head of solutions in Memgraph. And he will do a small presentation first to just give you an intro to what we are going to talk about today. Here is also Marko, Memgraph COO, and Mata, another member of the DevRel team with us. Josip, maybe you can share your screen and we can start. And the point is, if anyone has any questions, I think, Josip, you will be fine with people jumping in and asking questions also in chat, or just unmute yourself and ask questions. The idea was to share what is new with you in Memgraph. And because a lot of people had questions about subqueries and patterns in filtering clauses, this is why we decided to take on this topic. Josip, the stage is yours.
Yeah, hello guys. So a little bit of background. I'm Josip, a little bit more than 2 years in Memgraph now, head of solutions, working mostly in industries, figuring clients' needs. And in my free time, I do some coding. So in my free time, which I have very little, I decided to code subqueries and the exist feature, which has been requested many times, as in the community as well as with clients. It brings up a lot of opportunities like expressiveness and makes the querying much more intuitive and much more easy, since we couldn't actually do some stuff or reproduce some stuff that was doable in Cypher. So for example, if we could rewrite most of our queries in our way with match and optional match, but that was let's say insufficient. Queries tend to get very large, like with respect to the number of lines, and it makes total sense now to make that transition. Anyway, Memgraph 2.7 is out with a bunch of like new features. Subqueries exist, has been there like since 2.6. Analytics mode, which makes you import all the stuff a lot more faster for read queries, and I don't know, terminating long-running transactions, etc. So let's start with the presentation. Can you see the presentation?
Yeah, it's fine.
Yeah. Okay. So let's see what are the use cases of subqueries that we implemented. These are all my examples, and I'm terrible at giving examples, so I just made some dummy ones. But yeah, basically, if you have a match in front of a call, which is actually a call subquery, it can be a bit ambiguous, because in Cypher, call is also used for calling procedures, but it's not that. It's like call with curly brackets. It's calling subquery. So if we see this match here, do you see my pointer? You do?
Yeah, it's visible.
Yeah, okay. So so let's say we have two persons in the database. One is named not John and the other Alice. So this match here, if we had just this match here, it would return two entities, so John and Alice. But if we call this subquery, so this is just an inner query, which goes again into the storage and matches the animal. And of course, here we have like two animals, Rex and Lassie, obviously dogs. And then the result of this product here would be a Cartesian product, so 2 by 2. So here we have two results, here we have two results. 2 times 2 is 4. If we had here like 3 dogs, we'd get 6 results. So everything gets, let's say, joined with one another. But that doesn't maybe address all of our questions. So we may actually use bounded symbols. So what bounded symbols are? It's a pretty technical term. Maybe like there's some little bit lighter term in the industry, but it's actually a reference to the outer scope in the subquery. And if we do this match, we get two results, but now we can actually reference this person who was matched here, and then it behaves like a join in the relational database. We match the person with the parent and we return the parent, and now we are actually sure that all the persons have their respective parents named. So that's actually pretty cool. So use with whenever you need a reference to the outer scope. Let's go to the next one. So here we did some it's one of the uses is post-union processing, and here I haven't done any processing because I already said my examples are bad. But let's say we wanted here to return a name of the person and the ID number, but we wanted to actually list both the physical persons as well as I don't know, well, in Croatia that's called like law persons, which are companies, and then you have both like John and Memgraph, which they're actually ID numbers. And then after the call, you can do various things. You can collect, you can actually continue doing the query. Before that, you couldn't do that without the call, because you just do match, union, match, return, and then you get what you get. But now we have more expressiveness with this construct, because we offload this union into the call, and then we do whatever we want. So we can do where, we can do with, we can do aggregations, accumulations.
Okay, so you don't have to repeat your code in each part of the union.
Yeah. If you do I think before, if you wanted to do, let's say, an aggregation, you needed to do it like here somewhere and here somewhere. But now you actually get it returned all under two columns, and then you do with them like they're already there with you. Yeah. And not to mention, if you return this collect and this collect, then you need to, I don't know, give a plus sign to merge the two lists into one. So it was like a terrible chunk of work to do. Just yeah, and it's not a great user experience. Okay, so this one example is from Neo4j. It's called like observing changes from previous executions. I haven't really much work on these kind of queries, but however, you can actually call this method multiple times, and then you here actually get your work of units in the each iteration, and then after that you do accumulate, which actually corresponds to this 1, 2, 3. So it's all these, like, let's say, checkpoints in your tasks, and then you actually do a final match, which actually provides you with the total value. So it's kind of like a progress of what you've been doing. Like I said, I'm not sure like where to use this. Maybe in the industry, like when we talk to clients, we'll have more clarifications, but yeah, it certainly is kind of a cool feature.
Well, basically what you do here is just like the union, where you have repeated kind of queries that get joined together, and you deal with them at once. Here it's a loop. With this unwind, it's just like 3 calls, and you could have like a call with 3 union, one with 0, one with 1, one with 2, and you would have the same.
Yeah, that's true actually. Yeah, it's pretty basic, because here's like 0, 1, 2, and then here's like 1, 2, 3, and it's not like much of a logic. But maybe if something complex was written, then it would make much more sense. Yeah, like doing some iterations of work.
Yeah, when you do a union, you have a fixed number of sets. You do the union, and here you can input a list, and you do the same thing for different parameters. So it would be, you can do something similar to your union cases here.
Yeah, great, thanks. So yeah, and then we have these unit subqueries. So for each clause by itself, it doesn't return anything. It's an empty result. But since it's an empty result, that means it returns 0 results. So if we go back our first premise, which said we offer a Cartesian product. That means that if we match here and call, that means like, I don't know, let's say if there's one person and this for each does return nothing, it would be 1 times 0, which is 0. So actually that's an exception to cipher. And for each which doesn't return anything, we actually wanted to return, like we actually pretend to return one result, so all here P elements can be exhausted in the rest. So yeah, here actually we can do, let's say, unwind, and then for each we can do like multiple iterations of for each. So let's say I don't know, here we create multiple persons. For each person in the database we can actually do like clones. So let's say match P and then call for each, I don't know, 1 to 5, we create 5 more clones in the database. So yeah, let's see some invalid uses of call subquery, a little bit of syntax and what should you watch about. So here we actually have match n person, and then here in the call, okay, we don't reference it. So this actual n will not know anything about this one. But what you cannot do, if we already have this in the outer scope, you cannot return a variable from the inner scope that has the same name. So you need to actually rename it. And what do you do? What do I mean by rename it? So you return P, and then you have like 2 symbols. One is N, one is P. And then you have the Cartesian product in place. If you want to return like both, you can join them in a list and then unwind them. Let's say this second one. Yeah, so aliases. So you cannot actually return an expression, but it needs to be aliased. So this actually, we cannot parse in the query, just as we couldn't, yeah, I mean, we cannot, from the inner scope, we cannot guess what this is. But if we actually alias it, we have a symbol for it, then we can return it here. Let's see this one. What's this? Referencing other scope. Okay. So yeah, here we match the n symbol, which is a person, but call the subquery with referencing O. We don't have any O in the outer scope, so that's forbidden. You'll get an exception, and you need to reference. So if you want to reference, you must reference only the variables from previous scope. Yeah, that's all about subqueries. Do you have any questions? Later, I'll go through Memgraph Lab. We can cover existential subqueries, count subqueries, I think also collect subqueries, which are not yet supported in Memgraph, but I played with it a little bit, and yeah, it's much smoother now, a workaround now than when we have call, so it's a little bit easier, but yeah. So if you have any questions about subqueries, shoot now, and we get with the other part of subqueries later. Okay, then patterns in filtering clauses. That's how I named exists. Basically, why did I call it patterns in filtering clauses? It's because these exists can only be used now and where, and you cannot do like set something equals exists, just because we're still figuring out how to do it the best. It's not a problem, but we're just looking to gracefully add it to the system. So what exists actually does, optional match was okayish, but here actually you can, in exists, you can expand on the variable without actually doing additional symbols and without having additional columns in the database, and without like these excessive, and the optional match could yield nulls, and then like you can have a lot of edge cases. this exists actually behaves like an expression. So if there exists a pattern where person has been living in Germany, then it would say, okay, like here would say Vincent, since Vincent is, I think, living in Germany. So yeah, it would yield Vincent. Yeah, if there was no one who lived in Germany, then it would be 0 results. So yeah, that's basically it from my presentation. Yeah. Any questions about exists? You can actually do like stack these exists, do and or and stuff like that. So and you can actually feed here like multiple patterns. So it's not only this node, edge, node, but you can actually extend it with edge, node, edge, node. And if you have to query from 2 sides, then you could do exists and exists for left and right side of the, let's say, reference P node and stuff like that.
There's one thing about this exists. Our experience with Neo4j is with the query planning, sometimes it turns out that you get no benefits from exists where you would expect it.
Mm-hmm.
And compared to just filtering through optional stuff or different kind of expressing the stuff. We have some cases where we thought using exist would speed up things, and it did not happen. So if you want it to be very effective, you have to think about what it means in your query planning. It's just having the expression does not solve the problem of the query planning with this kind of stuff.
Oh yeah, that's true. That's true. I mean, I always like to do profile and explain and see how many hits did I have.
Yeah.
For example, if this is a super node, then expansion of this exists is very costly. And then
I mean, in this case, Germany will be a super node, so you will not want to expand this in the other direction.
Yeah, that's
but
true.
if P is a super node and Germany is not, then you might want to so you have to plan the thing in the exist as you do for the rest.
Yeah,
I'm not sure at the time being what's with Neo4j. We had no benefit using the thing. We said, oh, we have cases where we make an exist and it's gonna speed up things a lot, and it does not. But I'm aware of the complexity of the query planning, so it's not always solvable or decidable how to do things. Just wanted to raise awareness here around this stuff.
Yeah. Also, what's also worth mentioning is it depends like how the planner evaluates these expressions. So let's say if you have here like where exists, and let's say P age is something. So since you already matched this here, you already have all the data present from P. At the time when where hits, you probably don't have this information, but you have the information about the age. So I think it's better always to evaluate age. I mean, it's not from the user perspective, but from the database perspective. Like if an expression can already evaluate just based on, let's say, this P properties and evaluate as false or true, then you don't even need to do this exists and go into the storage and fetch again from the relationships of P. But yeah, like you have all the kinds of smaller improvements that you can make always in a database.
Yeah, I mean, the thing is, in your case here, you could have the pattern as a match, and you would get the same result.
Yeah, that's true.
But using the exists, you give an information that you are going to throw away the results anyway of this pattern match of anything you could match in there. So it's something you could benefit from the planning perspective. You would have to recognize this in the structure of the query, otherwise that I do nothing with the nodes that I matched here. So
yeah. We're still exploring what we can do. Like if something is not referenced or used later, like we can like throw that part of query planning away. But yeah, it's always tricky to do this.
No, it has to exist. I mean, if you have something, it would be the same as it has to exist. So you use it, you might want to start, like I said, if Germany, you have only 10 people in Germany in your big database, you want to start with Germany to get P and not start from the persons to go to Germany. And this is the kind of stuff you have to think about when you're doing this kind of stuff.
Yes, definitely. I mean, but it's always it depends on the data set, and actually the person querying knows the best the distribution of the data. So yeah. Maybe we can do Katarina one other education on, let's say, indexing, profiling, and like database hits, because like a lot of our users have been asking questions. Maybe there were like some queries that were slower. We did this command is called analyze graph, which makes the query planner smarter with optimizing indexes. So it will actually always, so if you have, like, if this was in a match, so P person living in Germany, and you have index on both country and name and the person, it would always select the index to expand from person, because it could have like less hits if it had less hits, if it had like less entities in the database. So that's always a good approach. Yeah, so that's basically it. I can
maybe
now
also one small thing from the community. We had a bunch of questions regarding the exist subquery that is available in Neo4j. What is the difference between this exist function in Cypher that you developed and the actual subquery call? Because, you know, there is like a clause called exist, just like call, that they do have in Neo4j. Not sure, Vincent, did you use that? But I saw that in the documentation. And people are asking, okay, if I use this query with exist clause, can I rewrite this somehow in Memgraph with this exist function and so on?
Yeah, sure. I've just written some like 3 examples with quick workarounds of how we can do things while Memgraph doesn't do existential subqueries and some other constructs. Thanks, Pete. I saw your comment. Really appreciate it. So next one, Memgraph Lab. Can you see Memgraph Lab?
Yep.
Yeah. So what I'm gonna do, I'm gonna insert this really small data set, and then we can actually see what we actually have there. What did I do? What did I do? Like PRS? I don't know. Run selected, graph results. So we have actually a really small data set. So we have Anna and John. So two friends, and they both have parents. And John Senior. Okay, so John Senior is 40, Mileva is 36, Anka is 46, and Mirko is 50. So yeah, what we want to do from this first example, okay, give me persons where at least one parent is less than 40 years old. So if we try with exists, I couldn't actually make anything meaningful out of it, but how would it actually look in Neo4j with existential subqueries? So what are existential subqueries? It actually exists, but it is an expression that yields true if the subquery returns at least one result. So we match a person, which would, so these here are actually, we match the person, so this would actually match all the 6 people, but where exists that P has a parent and parent age is 40. So John Senior is 40, so that doesn't make this expression true. Mileva is 36, so that makes John a candidate, which would pass. This exists here. And then Anna, she has parents of 46 and 50, so she doesn't pass. So actually the query would return John. So let's run this. Of course, it doesn't run because Memgraph doesn't support it. But yeah, give us just some more time. We're planning on doing like live coding sessions for the community, me and the CTO, just to where we solve some issues from GitHub that were reported. So be sure to check out that if you have time as well. Will be that would also be like live, and like you could ask questions about what are the internals of the system, and you could see everything in action while we do it. So let's get back to the existential subqueries. I have rewritten it here. So for every person we do a call, we reference that person, we get the person's parents, and then now we have two parents from Anna and John. We see where parent age is 40, and then return count star is greater than 0. So if one parent is greater than 0, then this would actually be true. We return that from the subquery, and then filter again, and then return P. So this actually gives us John, which has I don't know, his mother is 36 or something.
Yeah, this works, but you lose the opportunity of stopping querying when you find one.
Yeah,
Because
that's true.
Your query optimizer will not be able to extract from this count star greater than 0 that when he has one hit, when he found John, he can stop.
Yeah, it doesn't
And
have.
this is what Neo4j. This is why they use this subquery stuff, where they say as soon as they have one match, they can bind one result in the subquery. They stop.
Maybe if I perhaps if I did somewhere like limit.
Yeah, it would be better with a limit 1. Yeah.
Maybe it would work.
Yeah, but you.
Yeah, perhaps.
Yeah,
Yeah,
but
something like that.
It would be a better solution with a limit. You're right.
Yeah, that's true. That's true. Or return parents limit 1, and then with parents where I'm not sure. Yeah, it would need a little bit more tweaking, but yeah, let's not go into this because then I'll never stop. Yeah. But yeah, you said a really good point. So
yeah,
this is a workaround. However, it's a little bit less optimized, and depending on the data set, it could have a little bit to very much impact. Yeah. Let's go to the second one, and that's count subqueries, which we found on Neo4j's page. Give me a number of persons that have both parents 40 or above. So here is the
Josip, you have a question in chat from Michal. He wrote a suggestion of this query that we had before. Yeah, maybe we should try it.
I don't have a.
You don't see the chat?
Can you read it? Can you read it out? I don't have.
So let me see.
It's gonna be a bit complicated.
Oh yeah, match person that has a parent where parent age. Oh, you just wrote Michal. Okay. He just finds with a simple querying, like persons whose parents are younger than 40.
Also,
without,
that's true. That's true. Yeah, I'm bad at examples, so yeah.
Example is something that should be better, but yeah, Michal, I think you are probably right. I didn't see it in details.
Definitely, yeah. This definitely shouldn't be done with subqueries. So yeah, this count filters only if you have like both parents 40 or above. So that would be, I think, Anna. And let's run this. Of course, doesn't work. Let's try it the memgraph way for now in 2.7. We match all the persons. We go through the parents. We get the age. We filter it, and then we count again. And then we filter here that it equals 2, and it returns us the person I'm not sure, Vincent, like, what do you think now? Do we have any performance issues about this one? Since I think Neo4j does count 2. I mean, they could limit based on this one here, but if it was like something, I don't know, person prop, it could be dynamic.
There will be some case where you cannot where the gain is not that significant, but if you are searching like in lots a deep search for something that you want to have, and this thing should have certain property, and when you found one, you stop. It's not one hop like just like here, but it might be a multi-hop with lots of conditions and aggregates and kind of stuff. Then the gain is significant. On this kind of stuff, it's just like Michael wrote. You can write it even without the count. If you make a distinct person has parent where parent age 30 whatever, and here you would need a count because you want both parents.
Yeah. Thank you. And the third workaround, give me persons and parents of 40 and above age. So what they did here in the Neo4j documentation, they matched persons and then collected the parents and then returned the parent age. So basically all the ages of, so all the persons, but the ages of the parents which have more than 40. So of course, this doesn't work. What we do, we match all the persons, we reference them in the call subquery, we get the parents, we get age greater or equal than 40, and collect parent names. Okay, I actually collected names, not ages, and name them parents in best years of their life, and then return it. And then what we get, all of them, but here, okay, person, let's do here name, and then John has 1 parent 40 or above, Anna has 2, and then these ones is unknown since I haven't expanded the data set. But that's basically all. You're now an expert to write subqueries and exists function in Memgraph. Congratulations, guys.
Woo! Thank you, Josip, for showing us this. Does anyone have questions regarding these subqueries, or how we dealt with it so far in Memgraph, and what would be your suggestions for the next implementations? Maybe Josip, oh yeah, Vincent, you can go if you wanted to.
Oh, it's okay. I just said we are happy with every step you take towards being nearer to what Neo4j offers, or because it will be less work for us to write an adapter for Memgraph. And I think if you want to benefit from most of the ecosystem that's been built around Neo4j, it's just the way to go. Even if under the hood you are working differently because you have your skip list and you don't have agency lists and this kind of stuff. If for the people using the API, and I'm talking high-level API like Cypher, we get all the functions we get with Neo4j as close as possible. It's less work for us, so it gets more attractive for us. Try to be to connect to your store.
Yeah, I totally agree, and like the more compatible we are, the better, of course. And Josip, maybe can you tell everyone more about what's next in Memgraph? Like what are the next main features you'll be adding, maybe to Cypher or maybe to something else in Memgraph?
So like these existential subqueries and that, I think it's not currently like a major priority. However, like if we do have these community calls, and yeah, maybe should be show something like that we can showcase, and if there is like a golden C++ member, he can maybe understand what we're doing and then do contributions. But anyways, yeah, what we're doing, map projections. So that's something what we'll need for GraphQL. GraphQL also requires parsing of subqueries, since it's then easier to produce, to actually transpile queries from GraphQL to Cypher. So map projections are, I think, the last obstacle for us to have GraphQL. And what we're also doing, we're measuring stats in the database to have it exposed via Prometheus. So for being able to monitor Memgraph, observe like query latency, snapshot creation latency, number of transactions, bolt messages, basically everything you would want to observe, and then you can like plug it in Prometheus, connect it to Grafana, and you'll have a good visualization and know at all times about what's happening in the database, and so you can alert and react accordingly. I think that's basically it, but we're also pushing something on the disk storage for people who have less RAM available. So that's maybe a good thing for them. Yeah, we're seeing how will the performance turn out. But yeah, we're taking baby steps and then seeing how we can improve.
Is there anything special that maybe any one of you thought about that would be a cool feature for Memgraph? Is there some, I don't know, any feedback you can give us, like a feature you would like to see in Memgraph? What would be, if you can choose like one thing, what would be the feature that you would like the most? Josip won't get mad, I promise.
Like integrate ChatGPT with Memgraph.
Yeah. Maybe that's a good one. No fee. Okay, then I think Josip, you don't have to do anything. That's great.
Oh no. I always always have to do something. Yeah. Yeah.
And when you're talking about adding new parts of Cypher queries, and when you are implementing it, how are you actually measuring the performance inside Memgraph? Like maybe for someone who wants to know a bit more in depth. So are you measuring everything when you implement a new part of the query? In which way?
Yes, so we do have our own internal benchmarks, and then like whatever feature we do, and not only like expansion of the Cypher query, but also like, okay, now we're doing integration with observability. We're measuring stuff here and there, and we want to know like if that will degrade Memgraph's performance. So yeah, we have our internal benchmarks. We compare with the latest version, like how is the performance, did it degrade? Mostly when we add new parts of the Cypher query, we don't degrade performance of the current queries that we already have. But yeah, like it also varies on how much time you have to develop a feature. You can always do faster. I think for now, our exists branches that we have in where always execute, and I don't like that, and that could be optimized, like if you have these pre-executed expressions. So yeah, but there's always room for improvement. I mean, you got to always benchmark, because you cannot release something that degrades performance massively, because then it's your integrity is ruined.
Yeah, that totally makes sense. And I mean, I would say, of course, it's a great thing that you do that, so that people don't notice a big performance difference when, like, performance loss when something new is added. And regarding the benchmarks, not sure if you saw, but we actually released a new version of our bench graph. So it can be found on our blog post. Just a sec, I will send you a link here. So you can maybe read it through if you are interested, and we can talk more on the next community call about that if any of you would be interested. Here is the blog post. Yeah, you can read more about what we did in last period. I would say, make benchmarks even better based on the feedback we got from the community. There were a couple of stuff that people said, okay, but this should be better. How can I fire it up by myself and so on? So we tried to make that happen. And do let us know on Discord if you notice something, if you think something should be done better, or if you think it's great, share it with us. Actually, Ante is not here. He mostly worked on that. So if you have questions, you can always ask Ante also on Discord. Does anyone else have any questions? Like, you can ask anything you like, since Josip is here with us, and he's like our head of solutions. So he has, as I said, answers to many questions. Okay. Okay.
I'm sorry, I was on double mute there for a second.
Oh,
I do have a
okay.
question on performance. When you're doing in-house testing and you have these massive data sets you're loading into memory, and I did ask this in the chat, so I apologize for the double question, but what do you use when you're loading? What mechanism do you use when you're loading these massive data sets to load them as fast as possible? Is it CSV or what's
I think we have like so our queries are prepared already in Cypher, so we just read the file and then ingest it via a client in Cypher. I think it's the C++ client, so that's actually our fastest approach to do it.
Really? So instead of using the unwind method with a with the JSON object, it's faster to prepare the statements ahead of time and then just ingest those statements.
So what you can do if you when you first inject your queries in the database, you can do dump database, and then dump database gives you these Cypher commands, which are either create node or match one node, match second node, and then create an edge between them. I think that's the fastest approach. Unwind, it's okay, but I think this unwind gives unnecessary complications. We have recently made improvements to the load CSV. It should now I don't know, ingest like 20,000 entities per second. So and it doesn't use unwind. So I think that approach is better. So first, like, if you have dump database, do that. If you don't, then load CSV. But load CSV also, like, always use indexes. Like if you do match create, always do indexes, and like if like best performance will be achieved if you don't have like any crazy logic inside load CSV. So like the less lines in the load CSV clause or load CSV query, the better, and the faster the ingestion.
Okay, sounds good. I'll go ahead and run multiple methods and post the results to the chat just for grins.
Yeah, sure. So yeah, one other thing, I mean, we don't do it on like crazy data sets, since like if we encounter, we can also encounter performance issues on like lower amount of data sets. So on already on few millions of data, we can encounter if some performance is degraded, and that will mostly hold true for the bigger ones.
Understood. Thank you very much.
Yeah, I think that the most important thing that we should always repeat is create indexes. I think that many people come to our Discord and we first check, did you create indexes? We should create like a poster, you know, on our channel saying, did you create indexes? It was like inside joke in company, but yeah, definitely it can speed up your loading time.
And that's really interesting, coming from traditional database realm where indexes slow things down on ads. So when you asked that, I thought, oh, I don't have any indexes, I'm fine. when you're saying that's not fine.
Yeah, but you have to, in order to have an edge, you have to match the two nodes and get the IDs, the internal IDs of these nodes. You don't come with the internal IDs, and this is the difference to a relational database where you come with the keys already, so you don't have to do anything. You don't have the keys, you have to look for the keys. So yeah, this is why you need these indexes. But on Microsoft SQL Server, we dropped the indexes for massive import and rebuild them after that. And it's a major speed up, because otherwise in every every batch of data you put, they update the indexes, and they keep updating the indexes. And so remove them, import the data, and then re-index the stuff. This is the thing you do in
exactly, and that's why I was a little confusing in this realm, because it
yeah.
sounds like indexes will increase the import performance. So
yeah, you need the index on the IDs that you use to find the keys. So to say.
Got it. And thank you very much, Katarina, for pointing that out in the chat.
Yeah, whenever you have a match, so like in Pete's case, he actually had a merge of nodes. So merge actually does this match and create. So you need to be careful with those IDs that you are matching. And hopefully this will speed things up for you, Pete. So do let us know. If not, we can hop on a call and resolve that.
Oh, I'm sure it's 100% on our end, and we'll. But just for grins, I'm going to try importing. It's like 1.5 million through the CSV, load CSV through without the indexes, and then add the indexes and then run it just to,
So
just to see what.
What's another thing you can do is we have this command now, like storage mode in memory analytical. So what people tend to do is like switch to analytical mode, which allows for faster import their data, and then switch back to transactional, which then makes you all the database guarantees. You will
want to do that, and I've not tried it yet, but this is one thing I told Dominic the first time I tried loading data from Neo4j. I generated cipher L statements, so it just the cipher, and I said, it's kind of slow, and the problem was that the cipher statements, they were transactional, and you don't want that when you do massive data import. So that's really a good solution. I'll have to try that.
Yeah, thanks, Vincent. So yeah, storage mode in memory analytical. Maybe Matija, you can just submit a link to the chat.
I mean, this was announced with a release that this.
Yeah. It is.
Yeah, analytical mode is also part of 2.7. Yeah.
Okay. Are there any other questions? I think this was a good one. It's always issues on the import side. It's the first step, and we should definitely make it work the best. We are currently working on some kind of best import strategies guide on our docs. So the plan is to kind of give an overview of what can be imported in which way, and the tips on what is the best way of importing data, like the fastest in Memgraph, like you, Pete, asked me. And hopefully we'll have something ready next week to show you in our documentation. Yeah, Michal, what do you do if you don't import data? I don't know.
I mean, the thing is, if you're dealing with transactional data that comes just in small batches, it's okay. But when you start from scratch, like we want to explore big data sets, so we have this in Neo4j or somewhere else, and you want to put it in Memgraph and try our exploration queries. And the first thing we have to do is take these millions and millions of stuff and put it in there. So.
Yeah, definitely. Since like the step one always is importing the data, so that has to be at least as representative as it can be. So yeah, but hopefully with 2.7 and 2.7.1, it will all be addressed, at least in the load CSV and some other optimizations. So yeah, stay tuned for new versions.
Definitely, yeah.
we also parallelized, and I'm not sure if that's 2.7.1 or 2.8, the reloading of snapshots. So if your memgraph is down and then you want to restart it, we parallelize that, and that runs, I don't know, like on, but I think like on as many cores as you have, which is a good thing.
Okay, that's
for nodes
good.
and edges. Yeah, so
That's good.
we had a
Because
client.
what-
Yeah. Sorry, Vincent. Yeah.
Yeah, because what I do is I load the data and I wait for it to be loaded until now, and then I use the snapshot. But I was surprised that the snapshot did not.
Yeah, it was
load last time.
single threaded. Yeah, it was single
I mean,
threaded.
I'm a bit biased because I use a lot RDFox, and RDFox is the fastest loading kind of triple store you have. Obviously, they're in memory, but I have a very clever design, parallelized way of doing things and building the indexes, merging the indexes during the stuff. And this is the kind of issue you encounter when you build indexes and have massive parallel imports, is that you have to have your partial index and you have to have a good strategy to merge them.
Can you just maybe write in the chat like what's the name of the company? So I can check it out later.
Yeah, it's RDFox from Oxford Semantic Technologies. It's a spin-off from the Oxford University. It's a triple store and data log engine. So it does inference, and it's based on years of research by very, very good researchers at Oxford, and it has a very, very sound technological basis and theoretical stuff. So it's
yeah, no, it's really nice to hear about these university projects being like really adapted as it should.
But
I think there's like this.
It's not open source,
Yeah.
and it's quite expensive.
I think there's this like database. It's called KuzuDB. That's also from, I'm not sure which university.
Yeah, Oxford has had lots of projects in this in the triple store inference engine kind of realm, and this is where I come from. We started working on an inference engine using Neo4j as a storage for the data. It used to be an academic project, and this is why I know of this stuff. But what they don't do at all is they don't do graph analytics, so it's a very different kind of application.
Oh yeah.
They have a rule engine, so they do different kind of stuff. But if you try loading really big data with RDFox, you'll be surprised how fast it gets. It's C++ also, I think. So
yeah, I'll have to check it out. It's not so different. I guess the storage is not so different from Memgraph since it's a RDF store. So it's also some kind of connected triplets, I guess, together.
Yeah, the way the indexes are built and sorted is kind of special. You will find the foundation is published in papers, so you will understand how they build the indexes. At least some part of it is public, because it's just a spin-off. So they protect the product, but they do not protect the ideas. So.
Yeah, it's great to hear about a bunch of new technologies out there and the old ones, but still doing great. I think it was a great community call. Hopefully everyone enjoyed. It's awesome to hear your impressions on subqueries and patterns in filtering clauses. Thank you, Josip, for being here and presenting what you did. It's awesome to have a person who actually implemented the feature talking about it. If you have any other questions, feel free to join the discussion on Discord. And I'm going to announce the next community call once we figure out the actual topic, and you'll know everything on time, so don't worry. And hopefully we'll see each other on the next one. And I hope you like this format. We'll see if we are going to continue this way. I think it was good. Yeah.
I think having a topic is what got me in this time. I mean,
Yeah,
last time
okay.
my community call in December, I was along with Dominic. We had a
Yeah.
great chat, but it was nice seeing more people around.
Of course, I do agree. Yeah, thank you for the feedback. Okay, thank you everyone for joining. See you next time. Marko, you had something to say? Or no?
No,
Sorry, you just unmuted yourself. I thought that you wanted to say something. Yeah, fine.
just wanted to say thank you for coming here to everyone.
Yeah. Thank you, and enjoy the rest of your day. Bye.
Thank you much.
Hi guys.
Okay.
Bye.